Alright guys, so today I want to talk about some physics and things that plague aircraft today. And some of the problems that need to be solved that haven't been solved yet with aircraft. And the first one I want to talk about is wingtip vortices. And there's controversy as to why these form and what they do to the aircraft. But most people believe that they create drag because the airflow is being reduced on the tip, and that creates drag. And some people believe that the air actually spirals up, which it does in a sense, but there's controversy as to why this happens, how it happens, and how to stop it or reduce its effects. So I want to talk about why I believe it happens, and this may or may not be true, but I've come up with an idea on how to fix it. And I just want to talk about why I think this really happens. So I'm going to use this picture as my picture of reference. So on the top of the wing, obviously we're getting lift, so the airflow is traveling up over the wing and then exits here at a higher speed because it has to travel a farther distance. Meanwhile, on the lower air tip right here, or on the bottom of the wing, the air is flowing faster, but it's still exiting at a down angle because the top and the bottom airflows converge at a point which angles it down to provide lift. So the vortex tends to start more at the tip, and then as it goes back it creates the first curve and then spirals. And one reason as to that I've found is because the air flowing over the top, when it comes off the bottom here, because there's nothing stopping this airflow on the bottom to come up to the top, the air is moving faster up here, so the second it exits this bottom, traveling in this direction, parallel with the wing, it gets sucked up into the flow because the aircraft is essentially dropping through the air as these are being formed. So this entire wing is also moving down slightly to perceive for like the lift and the angle of attack and everything. So the air, as it exits, it actually moves in this direction, so not straight with this line, but the airflow is actually straight, slightly offset to that. So the air actually starts to move upwards and then gets sucked into the downward force of this wing up here, and then that creates a vortices. Now some of the ways to counteract this problem is to have these special wingtip things right here. They're called winglets, and they bring the air up and prevent the air from kind of flowing up onto the top of the airflow or the top section of the wing, which does still create a vortex, but it is a much smaller vortex, and that equates to less drag, but it's still not perfect. So I was thinking of a completely different solution to this problem, because this problem should be solved, and I believe we have the technology today to do it. I think we've just been going about it the wrong way. So I'm going to illustrate this the best way I can in how it would work with my mind. So let's say we just have a conventional wing right here. I'm going to do it in red with a, can I get the gray background? It's not super important right now. So let's say we just have a conventional wing. I'm just going to do just a very simple wing that is a common wing shape. Just going to draw it out like that. I'm also going to draw a front view of the same wing, and And alright, there we go. So here's our wing. Yeah, I know these two aren't scale, but we're just going to go with that. So the vertices go, or the vortexes move in this direction, pointing downward. So let's say all airflow is going this way, and the plane is actually traveling up in this scenario. So instead of having this big wingtip thing where it brings it up like this and prevents the airflow from kind of getting onto the top of the wing, which still does cause drag further along down the airflow path, what if we were to have an inlet, let's say here, so an actual tube throughout the interior of the wing that would then allow air to travel in and then out the wing. So airflow now enters in through a hole in the wing and then would exit the wingtip in this direction, going so the air would then come out this way and then be pushed. That way we won't have any there's no more circular vertice because the airflow is coming out at a direction, and that direction can actually also be angled down, so the airflow can not only just travel straight out, which would then leave us with a an interesting air pattern. Instead of there just being one airflow like this, we now have something that looks a little bit more like this, because we not only have the top airflow, which would be up here, we have the bottom airflow, and now we have a third airflow which would travel out like this, preventing the bottom airflow from actually ever getting up to the top airflow. This design isn't really perfected in any way, it's just an idea I'm throwing around, and I'm not sure how effective it would be. There is still probably going to be a vortex here that forms, but what this design strives to do is to not necessarily prevent the size of it, but to prevent the number of spirals. Let's say in a 100-foot distance with a conventional wing without this interior design, there is 100 spirals. This design strives to make that number of spirals a lot less, and those spirals may be a lot bigger. That would, in theory, reduce drag and do it very efficiently. It would also work at lower speeds with an actual fan being put in here, and this being actually forced induction. So you could actually force air through, and if you were to get that flowing at a high enough speed, it could probably eliminate all effects of a vortex. Testing out this design is considerably challenging, considering I have no tools whatsoever to design a wing like this and to test it in a air chamber or build an actual aircraft that would use this technique. But I just wanted to run this idea by you guys and just see what you guys think of it, because I've really been thinking about the physics behind how air works and how the vortices actually travel back, and how to get rid of that huge flaw. Because I feel like if we were to get rid of that vertices back there, then that would create a whole new aspect and really revolutionize the aeronautical world. But once again, this is just a dream of mine, so actually making this a realistic outcome is extremely far-fetched. But I am interested. It does have me thinking about different designs to get rid of that, and there are these newer wingtips, which Minix wingtip. It's a vortex design that is drawn out by this picture. You're supposed to stop the actual airflow or induce the airflow of the vortex and shut it down more. But this design is used primarily on Formula 1 race cars, and I've yet to see it actually applied on an aircraft. but I am extremely interested in how these aerodynamics work. And I think I'm going to wrap the video up here. Please comment any ideas, suggestions, or if you do know more than me, which is extremely realistic because this is all very new to me. Please correct me if I'm completely wrong, and please shoot me some math, some physics that I can understand to better myself, and that's kind of cool, and just future ideas that I might have. But yeah, I'm essentially just trying to eliminate this vertices, which we have airplane designs now that are equivalent enough to where they don't need, or efficient enough where they don't necessarily need to eliminate that. Like these aircraft function fine as they are. They do their job. They do exactly what they're designed to do. But if this design immensely affects the amount of drag an airplane sees while it's in the air, then I think that could really be world changing and revolutionary. Just to save fuel, conserve many different types of things. And yeah, I think it could all around be a very good, positive thing for the world and the future of aerodynamics.